This tutorial will cover the basics of how the Creative 3D Group uses the My Omniverse connector to export models, materials, and animations to Omniverse, along with how we set up our USD composition strategies. First, we're going to load the OV launcher and install the My connector. You can find this in the Exchange tab under Connectors. Install the latest version. This can take a few minutes. Once installed, you do have the option to go back to other versions if you click the down arrow. This will list all available versions should you need to regress. Once installed, you can go to the Library tab and then go to your Connectors tab. You'll see all available installed versions. You can select between them using the hamburger menu on the right. Launch Maya and do a quick check that the plugin was installed correctly. You will see the Omniverse menu in the middle top of the interface. You can also check the plugin manager to see the install path and what is installed. When working with the Maya connector, especially when working with existing USD scenes, it's useful to connect to a Nucleus server in case textures or materials are looking for data there. Under the Omniverse menu, select the Connect button and enter the name and alternatively the port number of the server. In this case, I'm using our hosted external server, GTC Viz, without a port number. You'll see the server name on the left and the corresponding directories if everything is correct. Now it will update to one of our internal servers, OV Content. It is important to connect to servers before loading a scene and/or save your work, as it will reset your Maya CSR when you do this. I'm going to add a material library as an example under the Omniverse settings menu as part of the material search path and material collection. This is how you reference additional MDLs into your scene. There are other ways, but this is the simplest when grabbing big libraries. I'm also going to echo all commands so I can see things in the script editor and see what's going on. Now I'm going to search for and find a material library on our content server. You'll see the MDLs being loaded. Now I'm going to click on the Hypershade window and I'm going to load an MDL to verify that I have the new materials loaded. At the bottom you'll see an MDL materials list, which I'll grab an Omni PBR standard material. Name it anything you'd like. You'll see standard PBR attributes such as albedo, reflection maps, and so forth. I'll mention it again, but verify your server is connected before you load your scene. Next, I'll load up our toy model and check that it's set up how I expect, including verifying the hierarchy and checking and setting pivots necessary for animation, as you cannot currently do this in Create. Since I want to animate the arm, I will go in and set the pivot at the shoulder. Now that I have our pivots set, I'm going to do a little hand wave and head turn animation that we will export out as a layer later in the process. I have to make sure that the FPS is set to 30 frames per second before I do this, as that's what I'm working in this project. Setting the FVF is important only insofar as it needs to match in Maya and Create. Otherwise, you can get some time scaling and odd animation that you're not expecting. Now let's move on to assigning materials and textures to the object. I'm going to bring up the Hypershade and add a bunch of MDLs, and then I'm going to add texture maps to the albedo, so as an example. I'm going to browse to my material and load it. You should see the textured material applied in the scene once you've assigned the shader to the object. Assuming you have hardware texturing turned on. You could also assign multiple materials to an object by selecting faces and assigning different materials to different faces. I'll quickly throw the face texture map on his chest in this example. When you assign multiple materials, if you open the outliner, you'll see a Materials tab and you'll see multiple materials attached to one object. I'm going to load the fully textured model for speed to do my export with. You can see in the hypershade, all of the MDLs show up as green Omniverse logos. If you select one of the logos, you will see various maps applied. Let's export the toy as a prop to USD on our local drive. Go to the Omniverse menu and select Export. Set your export options to prop with export selected on and use animation toggled off. Make sure to have the include MDL checkbox on and include dependencies. And finally, make sure you specify default prim. This is typically world. Save this to a convenient location on your local hard drive, naming it something you'll remember. If you go to Windows Explorer menu and go to that directory, you'll see that it exported a bunch of materials and textures in a USD of the geometry and bindings. It's a bit messy. We're going to eventually collect this into a more compact package, but first we're going to verify that we got what we expected by loading Create. For the launcher, I'm going to load the latest version of Create. In the content browser, I'm going to navigate to the local hard drive location that I saved our data, and I'm going to double click on the file to load it. It'll take a minute or two for the materials to instantiate, and then you should see your character. You can add a light to quickly see it lit. You can look through and see the same hierarchy. You can see all the materials with the texture assignments that you did in Maya. In order to simplify the exported data, we're going to run a collect on it and create. Go back to the USD file in the content browser and right-click and select Collect Asset. Specify a flat collection and select the directory where you want to collect it. In this case, I'm using the default location parallel to the USD file, collected toy Jensen. It may take a while depending on how complex your model is. After a moment, you can navigate to the collected directory and you'll find a nicely organized scene, which we will further break apart into layers for flexibility. I'm going to export the animation I created earlier as a layer that we can apply to our prop and create. This is where having a good hierarchy comes into play, as the animation layer matches up motion based explicitly on hierarchical naming. Select the top level of your prop and toy and select export from the OV menu. Switch the export pipe to prop anim with export selected. Check your frame ranges and make sure the default param is still set to world. No need to include any of the other toggles now. Save this to a location that's also convenient alongside your USD file. To apply this animation data, we're going to go back into Create and use the Layers menu. We're going to load our original prop, and then we're going to load the animation layer over it. The overrides present in the animation file should cause the character to move as intended. If you hover over the bottom part of the screen, the timeline will pop up. You can scrub it and see. It doesn't pop up. Look under the Eye menu at the top left of the screen and make sure timeline is enabled. To disable the animation, simply toggle the eye on the layer in the layer editor. Now I'm going to jump back into Maya and create a quick camera animation that will export. I'm going to export this a little differently and do this as an animated prop with the animation built into the USD file itself. Select prop, export selected, check your default prim, and check use animation and include cameras. Select a location alongside your earlier animation. We typically name our cameras with the frame ranges in it. Now go into Create and add this as a third layer. Now if you scrub the timeline and make sure the camera is selected under the Camera tab, you should see your animated file with the animated camera. We're going to copy our local exports up to a Nucleus server in the cloud. You could do this directly from Maya, but since we've already connected to a Nucleus server, what we like to work locally is for speed, especially when we're working with large files, and it gives us a backup before we upload it. Now that we've exported everything, a couple of ways to export to a Nucleus server. First, I'll cover mounting a Nucleus server as a drive. In the OV launcher, under the apps, install the latest version of the drive. Once installed, launch the app and you'll see a place to enter your login credentials. Bring up a Windows Explorer and you should see the O drive mounted for you. Open up a second Windows Explorer to your original collected data location. In this case, I'm going to copy over the camera clip file. Next, I'll show you an example of uploading data directly from the Create browser. Launch the latest version of Create. Go to the Browser tab on the left. Make sure you have an Omniverse server connected using the Add New Connection tab. In this case, I'm going to connect to OV Content and call it Demo. Go to the area you want to upload your content to. Once you're in that directly, you can right-mouse click and say Upload Files and Directories. Then go to your local disk, find the file you want to upload, select OK. In this case, I didn't do it quite right. I selected the wrong directory, one level too high, so I'm going to clean it up by just deleting the extraneous files. Now I'm left with just the collected toy file. I'm going to use the web interface to conform our data to a layered workflow. I'm going to navigate to the directory where I've uploaded everything. I'm going to copy the camera clips by dragging and dropping in the web interface. This is how we typically upload data. Good. I'm renaming it to match. Next, I'm going to go into the materials file. I'm going to find my textures. I'm going to control-click all of the textures and copy them to the parent directory where I want them to reside. I'm going to do the same for the materials. Go back to the directory where you uploaded your files to. Now load your main prop. We're going to start breaking it up into layers. First thing to do is delete the materials. Now we'll save it a few layers back in our model directory as the model with version 1. You'll see it's gray with no materials applied. I'm going to reload the file. I'm going to delete the model but keep the materials. Also delete the light. I'm going to save this under the materials directory as v1. The material pathing would be wrong, so I need to go in and change the pathing using the USD path tools. I'll click the recycle button to see the texture paths. Then I'm going to simply copy and paste the paths as needed and replace them. In this case, I did it wrong, so I'm going to undo it and then correct it. It should be textures and then the name of the texture file. The same thing needs to be done for the materials. You replace the paths to see what will happen, then you apply the paths on the left to actually force the change. As mentioned in Peter's video, we need to silo our data with referenced files. And we're going to make holders for the reference files, so just simply a reference to the original data. We're going to rename it to be Toy Jensen in this case, both in the material file and in the model file, so that the hierarchies will align once they're loaded as layers. You create a reference by dragging and dropping the model into the scene. You'll see the little arrow turn to an orange arrow to show that it's a reference. Now we'll create a bridge file to load both of these layers, and you'll see the materials get properly applied now, since the hierarchy names match. I'm going to insert both the model and the material layer. Now I'm going to make a look development stage under a different default program called working. When you merge these files later into shots, the working file will be left behind, as the default prim is typically the only thing that gets merged unless specified under special circumstances. I'll take the world default prim and name it working. Then I'll go to the sky material editors and I'll drag and drop a sky in my scene. In this case, I just grabbed a hotel room. I delete the environment, reparent the sky material to the working default prim, and save that file as a working layer in my deltas directory. Now I go back to my original layered bridge file and I'm going to add the working file. Now if you look at the stage, you'll see two prims, a world and a working. This is useful for when having lighting setups that you don't want to translate to shots later, since they'll be individually lit by a separate artist. Thanks for watching.